Amrita Vishwa Vidyapeetham is one of India's premier top-ranked universities which focuses on transforming lives through learning, research and innovation. The university was established 19 years ago in the year 2003 and has made significant achievements in a short time. Education for life, education for living. Amrita University is guided by the thoughtfulness of our Chancellor, Amma, who laid down the philosophy of education for life by placing equal stress on education for a living. It is this vision that led to the establishment of a vast network of educational institutions that provide modern education while imparting the traditional values. While the pursuit of academic excellence forms the core of Amrita's success, it also undertakes the responsibility to shape the whole character of youngsters with love, care and compassion. The university is headquartered at the foothills of the Western Ghats in Coimbatore, Tamil Nadu, and has 5 other campuses spread across South India in Amrithapuri, Kerala, Kochi, Kerala, Bengaluru, Karnataka, Chennai, Tamil Nadu, and Mysore, Karnataka. The university will soon launch its new campuses in Amravati, Andhra Pradesh, Faridabad, Delhi, NCR. Our inspiration, a renowned humanitarian leader and spiritual leader, Amba is the Chancellor and guiding light of Amrita Vishwa Vidyapeetham. Amma's concept of education, stress on research and commitment to instilling universal values have come together to shape Amrita into an institution where the latest achievements and discoveries combined with compassion and service-mindedness. As Amma said in 2010 when the State University of New York presented her with an honorary doctorate in Humane Letters. Rankings. The multi-campus, multidisciplinary research establishment is ranked as 5th best university in India 2021 by National Institutional Ranking Framework, NIRF. We have also been accorded the status of Institute of Eminence, IOE, by the Ministry of Education, Government of India. A testament to our pursuit of excellence is the NAC A++ accreditation score, the highest possible. NAC accreditation measures universities for excellence in curricular aspects, teaching, learning and evaluation, research, innovations and extension, infrastructure and learning resources, student support and progression, governance, leadership and management, institutional values and best practices, global impact and international collaborations. Among the private educational institutions in the country, Amrita has entered into MOUs and collaborations with more than 450 leading universities around the globe. Students also benefit from our relations with industries and interactions with top management of multinational companies. These collaborations facilitate student exchange programs, student visits, industrial training, and project guidance under reputed corporate entities. Placements. Placements at Amrita have always been best in class, with students usually having more than 1 job offer. Some students have up to 3 job offers by the end of their course from reputed MNCs, be it engineering, management, life sciences, arts or sciences. Amrita is a place where the world's best companies look for talent. More than 200 companies visit the campus every year, and the average salary offered to our students is 5.8 lakh per annum. Meanwhile, the highest package offered is 56.95 lakh per annum, and the highest stipend for internship is rupees 80,000 per month. Amrita's Technology Business Incubator, TBI, is a non-profit supported by the Government of India that funds, mentors, and nurtures ideas by startups and entrepreneurs. It focuses on developing innovations in the areas of information technology, cybersecurity, networking, social media, and more. The TBI startups have obtained multiple awards and recognition, both from India and across the globe. Till date, TBI has incubated more than 75 startups and mentored 216 startup ideas with 0% loss from investments. It funds up to 1 crore rupees per startup and has opened up many more funding options through its partnership with venture capital firms and angel investor networks. Amruta TBI is one of the only 6 incubators selected to be world-class under Niti Aayog's Atal Innovation Mission. Campus life. A home away from home. At Amruta, we believe in a holistic approach towards our students' development. To augment students' classroom learning, all campuses provide students with digital and central libraries, quiet study centers, seminar halls, e-learning studios, computer labs, and campus-wide free Wi-Fi. The university encourages both indoor and outdoor sports and games, and there are world-class swimming pools, gymnasiums, stadiums, and games arenas. Various clubs cater to the artistic and scientific minds of the students. If you look around all of Amruta's campuses, you will see the prevailing educational environment is in communion with nature. The sand, the seas, and the sky define the backdrop of these temples of learning. It vibrates with an energy of togetherness and encourages us to live in harmony with everything around us, including a unity within ourselves. This setting is suited to instill both learners and the learned with the courage and wisdom to face the challenges of life. The campus at Ettimani is considered India's most picturesque. It is like an oasis in a desert. What started out as a barren landscape underwent a miraculous transformation through the university's tree planting project. Today, there are more than 1 lakh trees growing there, the most extensive collection in number and species on a university campus in South India. The Live-in Labs program originated from Amma's idea to bridge the rural and urban divide by sending university students to remote villages in India to understand the everyday difficulties faced by people living there. The program is designed to be a multidisciplinary real-life learning experience offered to both international participants and Amruta University's faculty and students. The lab's objective is to expose youths to day-to-day problems faced in rural communities with a 2-week to 6-month periods of live-in internships in Indian villages. It also aims to inspire them to dedicate the knowledge and skills they acquired at university to help develop practical, cost-effective solutions to the challenges faced by the villages. Researchers at Amruta Vishwa Vidyapeetham partner with senior scientists at world's leading research universities to innovate new ideas and invent new products, applying existing technology towards solving some of the world's most pressing problems, from disaster management to assuring access to education and the management and cure of diseases. This effort reflects in Amruta's national and international research rankings. India's first UNESCO Chair on Women's Empowerment and Gender Equality. Empowerment through Innovation and Technology. The Center for Women Empowerment and Gender Equality is a research-focused academic center for promoting gender equality and fostering women's empowerment with a special focus on using technology and other innovative methods. This center will offer diverse courses in key focus areas, pilot radical ideas, and collaborate with leading universities and institutions. The Amala Bharadam Campaign, ABC, Clean India Campaign, was a program pioneered by Amrita, aimed at improving public health and restoring India's physical beauty. The project was launched in 2010 during Amma's 57th birthday celebrations, and through this campaign, volunteers undertake periodic cleaning of roads, markets, temples, government offices, and hospitals. As a part of this campaign, garbage was sorted and either recycled or properly disposed of. Amrita Vishwa Vidyapeetham, along with Kerala's Prisons and Correctional Services and Tamil Nadu Prison Department, initiated Amrita Yoga classes and IIM Technique meditation sessions in 2018 to address and transform the physical, mental, and emotional health of prison inmates. Our goal is to teach yoga and meditation techniques to help the prison inmates become more self-aware. They learn to breathe with awareness and manage emotions through these exercises. Ours is a changing world. It needs people who can adapt to change, with minds that can expand and include change, and yet hold human-friendly values that can withstand all changes. Which is why the world needs education that shapes the minds of these people, and which is why the world needs Amrita Vishwa Vidyapeetham. Education for life, education for living. A university where future is driven by imagination. Experiential learning creates diverse opportunities, where industry exposure and international partnerships help you sail. Come, start your journey towards success with Amrita University.
There's a place where the best minds come together, work to end inequalities, work towards transforming lives. This is a place recognized as one of the world's best universities. This is Amrita, now ranked among the top 100 universities in the world and ranked #1 in India. Amrita University.
There's a reason why we pick up the highest grades nationally and internationally, year after year after year. That reason is you. Now, with an A++ accreditation from NAC and consistent rankings among the top universities in NIRF, Amrita, we get recognized because you must.
You can start now.
Hello, am I audible?
Yes, yes.
Yes, yes, you can start now.
Yes. Okay, thank you. So hi, ma'am. I hope my audio video is visible, and also I have shared the screen. I hope it's also visible.
Yes, yes, yes.
Okay. Thank you so much. So hi student, happy evening. And I welcome you all to the day 3 of Engineering Foundation program. So I'm really happy towards today's session. That's a very interesting topic. And I hope you all are really excited towards today's session. So we have covered one physics and mathematics topic, and today we'll be covering another physics topic. So it's semiconductors. It's a very small thing, but it has a lot of advantages of a lot of things. It's there in every area that we're using. I know maybe in your 12th standard you have studied something very basic about the semiconductors. So I would say it's a very small thing that actually controls the whole world. We have never heard about semiconductors this much, maybe before the COVID and all. So once after this lockdown have ended, I think in a lot of newspapers, there are lots of news which come with the subject of semiconductors. Like there is something called semiconductor shortage, a lot of things are happening. So there is a lot to understand about the semiconductor, maybe why this much shortage is happening, what's the reason, maybe about the semiconductor industry, a lot more things about the session, about the area called the semiconductor. So I hope the session will be interactive and you students can type your opinion in the chat box. So just want to have an understanding. I have a question to all of you before starting the question. How many, it's just like, do we have a semiconductor industry in our India, in our country? It's like, are there any other places where some industry or some companies producing semiconductors in India? How many of you feel like we are one of the producers of semiconductor in the world? Is it so? You can type a yes in the chat box. So I'm waiting for your reply in the chat box. And maybe I would say it's a very hot topic nowadays, and maybe as you students will have more information than me when it comes to the subject of semiconductor. I think nobody has replied. Do we have a semiconductor company or something, semiconductor manufacturing units in our country where they are manufacturing semiconductors for different equipments? I think I'm not able to see anybody typing. It's completely fine. And before starting today's session, I have one more thing to discuss with. How many of you have seen the semiconductors? It's like, how many of you have that experience? How many of you have experienced a semiconductor? Maybe some of you feel like, why she is asking this? It's like, how many of you were able to understand its components? How many of you were able to recognize its part? I would say it's a very small thing that's there in every area around us. I would say it's there in diodes, it's there in transistors. It's a small chip that controls a lot of things that is happening in the world. I hope you are able to follow this along with me. So what is our today's session is related to the basic of semiconductor, the basic idea of semiconductor that you have studied in your school, about the definitions, maybe about different types of semiconductors. Then we will move on to something which is related to the industry. Maybe about the application, about the different sectors which are the consumers of the semiconductor industry, or the concept of semiconductors or semiconductor. Okay. So yes, let's start. I hope the diagram here is visible. I'm looking into the chat box if anybody is typing anything. I hope this diagram is very common to all of you. I think I have taken this diagram from your textbook itself. So here you can see a conductor and an insulator and a semiconductor also. You know about these different category of materials, right? So a substance, we know it when it conducts electricity, we call it as a conductor. And I would say these conductors have a low resistance, and that is something which helps them to conduct electricity. And here in this, I have mentioned some examples, something like copper or these materials or aluminum, they are good conductors, right? What is insulator? The very basic definition that you have studied. Those substances which do not conduct electricity can be called as an insulator. It's like they'll have the higher resistance. So this conductors are having lower resistance, so it allows the electricity to pass through it. And as insulators, they are having the higher resistance, so it's like it will not be able to pass through it easily. Here I have described some examples also, glass, rubber, etc. Some of the examples. Now, what is something called semiconductors? Can anybody give me or provide me the definition of semiconductors? Ma'am, am I audible?
Yes.
Okay. So can anybody, because students are not typing in the chat box, so that's why I was asking.
Yeah, you
so
are audible.
Yes, thank you. So can anybody type what is semiconductor? So those category of elements or those category of substances which have properties between these two. It's like between conductors and between conductors and insulators. We call them as semiconductors. So they are also having certain category of properties or certain type of electrical properties. It's like a device which allow electric current to pass through it with a particular voltage or maybe with particular heat. Different background conditions are there. So these type of materials are called as the semiconductors. That's what the base definition of semiconductor. So they are a class of elements having conductivity between conductors and insulators. The very basic theory that we have studied in our school. The class of elements which is having conductivity between that of a conductor and an insulator is called semiconductor. So I'm not asking you to type the names of semiconductors. I know it's already there in the slide. We know about carbon, about germanium, about silicon. So I would ask you to type maybe the other examples of semiconductors maybe in the chat box. Maybe it could be something like a combination. We have different names, right? Different types of semiconductors. Maybe any type of semiconductor, you can just type in the chat box. What are the category of those semiconductors? If yes, it would have been great because it's a topic that you have already covered. Yes, I think we'll move forward. So what is the classification or what are the different types of semiconductors? This is something which you have studied in your school. About the classification of semiconductors. We know there is something called silicon, there is something called germanium, there is something called gallium arsenide, there is something called selenium. So all these are the different classification of semiconductors. A semiconductor in its pure form, you call it as an intrinsic, and it's like when impurities are added, you call it as an extrinsic semiconductor. Are there any names for the classification of semiconductors or are there any other classifications for semiconductors? It's a very important thing which has done a lot of changes to us, right? So the other classification, we can call them as elemental semiconductors and compound semiconductors. I hope you have heard these two terms about the elemental semiconductors and the compound semiconductors. Something of same sort of intrinsic semiconductor as well as extrinsic semiconductor. So elemental semiconductor is the same thing, the semiconductor in its pure form, because it's made up of a single element. And you all know the examples, right? Silicon is a very good example. And what can be the compound semiconductor? It is something called the, it's like, I would say, germanium or silicon. It's the intrinsic or the intrinsic semiconductor. So what are the extrinsic semiconductor? What can be the extrinsic semiconductor? If I'm going to do something with a material, I want to change its conductivity. I want to improve its conductivity. Maybe I want to degrade its conductivity. It's according to me. I'm going to work with it. So the conductivity of a semiconductor can be improved by adding some amount of impurity to it. So the process is called doping. I hope everybody heard this term, doping. You have studied it. The process of adding impurities to the pure semiconductor, thus making it more conductive, or it's according to your need, maybe improving the conductivity. So this process is called doping. And whatever we are adding, we call it as a dopant. Whatever material we are adding as an impurity, we call this as a dopant. So the process of adding an impurity or impure atoms to a pure semiconductor is called as doping. And this is a very important part of extrinsic semiconductor. I would say, if I'm having an atom, whatever the element may be, guess whatever the element may be, if it is having 10⁻⁷ atom, maybe for the process of doping, I'll just change one atom. I'll just add one atom of impurity to it. It's according to the need. Maybe I'll add just one. So it is transformed into a semiconductor, or it is transformed into a compound semiconductor. So what are the examples of the compound semiconductors? As it's a combination of different materials, what are the examples of extrinsic semiconductors? Can anybody name any extrinsic semiconductor? The basic part that you've studied in your school, in your textbooks. I would say gallium arsenide is an example. Silicon carbide is an example. Indium phosphide is an example. I would say gallium arsenide, indium phosphide, a combination of all the four. This is also an example of compound semiconductor. So where we have a combination of all of them. It's gallium arsenide, gallium nitride, or I would say silicon carbide, gallium, indium phosphate. Different examples are there. So I hope you have received an idea about the classification. It's just compound semiconductor, those category, or intrinsic or the extrinsic. Something like semiconductor in its pure form and a semiconductor in it's like changing its conductivity by adding some impurities. Now, you know about these elements, right? I have just taken a screenshot of the periodic table, so you can see the elements here. In the diagram, you have the 14 elements. So these group 14 elements in the periodic table has 4 electrons in the outermost shell. It's just like we are going to talk about deeper into the bonding part. So the group 14 elements, according to our knowledge in the periodic table, they are having 4 electrons in the outermost shell. So they have the ability to gain or lose electrons equally at the same time. So once we have a pure silicon, it is having the capacity to form bonds with the neighboring atoms. And we can do the concept of doping or the process of doping that we have already discussed to increase its conductivity. So this is something which we are following or which we are doing. So we have discussed 2 classifications. As of now, we have discussed 2 classifications of semiconductors, that is intrinsic or the extrinsic. Are there any other classification? Or do the semiconductor is having any other classification? I would say, is there any classification for intrinsic semiconductor? Or is there any classification for extrinsic semiconductor? I would like this session to be interactive. So yes, if anyone is having an idea about the classification of semiconductor, you can just type it in this chat box, whether there is a classification for intrinsic or extrinsic semiconductor. Have you ever heard about 2 types called N-type and P-type semiconductor? There is something called N-type semiconductor and P-type semiconductor. Now I think you have received an idea. So an N-type or P-type is the classification of extrinsic semiconductors. Those are the semiconductors or the category of semiconductors in which we have performed the process of doping. So they are classified into 2 types, N and we used to call them the negative and the positive, right? So when it comes to N-type semiconductor, we have something called phosphorus and arsenic. We know when it comes to the phosphorus and arsenic, we know it's pentavalent. What does it mean is it has 5 outer electrons. So when these pentavalent electrons or when this pentavalent is added to the silicon in small quantities, I would say the first one will be free. It has nothing to bond, or there will not be anything to bond with when it comes to the 5th one. And it will be freely moving around. So it's like there is some extra charge that's there. It's an N-type because it's a negative one. So these electrons will have a negative charge and we call them as an N-type conductor, N-type charge carrier, because majorly it will be of negative charge. So I hope you have received the examples also. When it comes to phosphorus and arsenic, it's the type. Now what about P-type? It's mostly with boron and gallium. The P-type is mostly with boron and gallium. And in their case, they are having only 3 electrons in the outer part. So all of you know about the hole concept, I think so. So when this is being mixed with the silicon lattice, there will be holes. So there will be no electron to form a bond. So when there is an absence of electron, it creates a positive charge and hence we name them as P-type. And these holes in the electrons will accept them. So this is how it becomes the P-type. Because we know the holes has the property to conduct the current. So hole will accept the electron maybe from any neighbor and it will move. So this is something called the P-type. So we have covered the basic theory about the definition, about the types of semiconductors that you have studied in your school, the basic idea. Now I think I have a video. Yes. What is actually the reality of semiconductors? Have you ever thought we are using it from the time we are just waking up in the morning to the time we are going back to the bed. It's everything that we are using. We can call them as the hidden champions in our life, in our day-to-day life, helping us to do a lot of activities. So I have a small video to all of you. So just go through the video. It's a very interesting video. So how many of you just understood what the video was with? You could see a lady who she was sleeping. So when she suddenly wake up, she was checking her phone. So nothing is there. She was going to do a lot of things. So what will happen if we are living in a world without semiconductors? Or is it something like one day I'm suddenly waking up and nothing is working for me? Even my toothbrush, my mobile phone, my watch, my hair dryer, nothing is working because all of them has something called semiconductor. If the semiconductors were not there, we would have not survived, or we would have not used all these things in our daily life. So I hope you have received some idea. It's not like we are having an idea that it's not being sold in shops. We will not be able to go to a shop and buy something related to the semiconductors. It's there in every equipment that we are buying. In every something related to the electronics part. Every electronics appliance consists of something called semiconductor. Maybe sometimes it's hard for us to understand, but in fact, it's used in a lot of the appliances. I hope you have received an idea. Now, let's see some of the examples where the semiconductors are there. It's being used in, I would say, temperature sensors, maybe in the air conditioners. I would say, you have heard about the rice cookers, right? It's like, it's just these cookers in which they are able to perfectly cook whatever item it is because of the semiconductors, because they are able to control the concept of temperature in these rice cookers. So see, in which all areas we are using it, maybe in the CPUs, maybe in our personal computers, maybe in cameras, maybe in refrigerators, maybe in LED bulbs, everywhere you can see the concept of semiconductors, or everywhere you can see semiconductors being used. I would say another example, it's like, how many of you know about, we all used to go to ATMs, right, to withdraw cash. So in the operation of ATMs, the banks, ATMs also, maybe in trains, in internets, the internet, everything related to the communication, everything related to the networking, everything related to medical, I would say the logistic systems, the transport systems, everywhere there is something called semiconductor. And how many of you know that in our cars, we are using semiconductors? In the cars, we are using, or we do a lot of things. We understand a lot of things with the help of semiconductors only in our vehicles. It's something called the car mounted semiconductor devices. How many of you know about the ADA system? We'll be discussing about the ADA system today. It's the advanced driver assistance system, where these semiconductors are used in the form of different sensors, which is helping us to drive, which is helping us to identify a lot of things. So we'll discuss about all of them in detail. We are mostly concentrating today on healthcare, automobile sector, maybe networking, and all of those areas. Now, I think we'll move on, or we'll start with the history itself. Where it started, what's the change? It all started with 1950s. That's the history of the semiconductors. It's like the transistor concept, the rectifier concept, or from there it started. You can see it in the figure, the transistor radio, the silicon transistor. Then it's all about the memory, how it changed. It's 1 KB DRAM, 64 KB DRAM, or 1 GB gigabit DRAM, or how it changed. So it's there with the transistor radio, it's there in the cloud, it's there in the video game that you're using, it's there in the personal computers, it's there in your mobile phones, it's there in your smartphones. So see how it's affecting us. So even if after this, the IC was invented, the IC era, a lot of things have happened, right? So it's there with the electronics part, or the electronic equipments, maybe from a longer period. even if it's related to the VLSI technology or the ULSI technology, the ultra large scale or the large scale or the very large scale technology, it's still there with everything that we are using. It's there in every corner of our society and it supports us in our everyday life. So you can see some of the applications of semiconductor in the upcoming video. Yes, I hope the video is playing.
Okay, Superman, your superpowers are extraterrestrial, but my superpowers come from this world. They're terrestrial and invincible. Don't believe me? Thanks to me, your smartphone takes crystal clear shots of all your adventures. Ever since you got a smartwatch, I've been keeping an eye on your fitness. While you're sitting here, you can come to the rescue anywhere in the world in real time, thanks to augmented reality. And in your home, I make sure the temperature is perfect for superheroes, and I can take care of all your other creature comforts as well. When it comes to flying, well, I have to say that Ingenuity, Mars helicopter, flies a heck of a lot straighter than you do. And if you decide to go by car, no problem. I'll always be with you as your guardian angel and smart sidekick. What's the secret of my superpowers? The power of semiconductors, the building blocks of the future.
I hope everybody understood how semiconductor is there around us. It's there in everything around us. I hope you understood how powerful these semiconductors are or how powerful they are in controlling our lives. Now, before discussing about ICs, we'll start with the loop itself. We'll start with diodes, we'll start with transistors, and then we'll move on to the ICs. Yes, I know all of you have heard about these microprocessor chips, the transistors, etc. So it all started with a diode. We would call this diode as the simplest semiconductor device, or I would say diode can be called as a regulator, which blocks or it blocks the current flow in a particular direction, or it allows the current to flow in one direction, it blocks the flow in another direction. That's what the basic concept or the basic introduction started, and it was with a diode. It's being used in different equipments, right? So that concept has now come to something called the semiconductors or something called the IC chips. So here in the case of, I would say, let's imagine a device which is working with batteries. So in that case, if I'm putting those batteries in the reverse order, I would have just put that battery in the reverse order, any device it may be. So we'll have to protect the device, right? So if you insert these batteries in the backward direction also, the diode is just protecting the device by blocking the current flow in one direction. Now, maybe when it comes to transistor, we all heard about this transistor is acting as a switch or as an amplifier, which makes it functioning, which makes it useful for different applications. Maybe the gates, maybe in microprocessor chips and all. I would say transistor is created with 3 layers. You know it, right? The NPN or the PNP. So it is something like I would say 2 diodes back to back, which controls the flow. It's like we are providing the power, or I'm not going into the technical details. So just providing the power through the sender, and it allows it to flow through it. So how many of you have seen a chip? It's like maybe a silicon chip. It's a piece of silicon that can hold maybe hundreds or thousands of transistors. So something called IC, an integrated circuit. So you can deal with maybe microprocessor chips, you can deal with different gates. So all these things form a part. So it's an electronic device which comprises of numerous functioning elements on a piece of silicon substrate. What can be an IC, or what is called as an IC? It is an electronic device which consists of different functional elements. It could be transistors, it could be resistors, or any of these elements, and they form something or a device which is called as an IC. I would call this as a silicon semiconductor substrate. You could see this diagram. So I have just put a diagram. There is a diagram in this slide where you can see a silicon wafer, something called 8 inches diameter. So it's the base part from which we have made an IC. So it's the basic silicon substrate part. What we have done is we have sealed it in a package with multiple terminals, and this here it goes. We have sealed it inside a package with the help of multiple terminals. So these ICs can be made up of the silicon wafer. It is then cut, it is diced, and it is added with numerous IC chips. So this is sealed in a package. Why? Because I would say these chips will be affected by maybe very small electrical charges. So we need to pack it, and that's why this packaging is like this. Have you ever thought about why the structure is like this? Because if it's not protected, it would be broken or it will be affected by a lot of charges. That's why the structure is like this. I have provided another view also, the cross-section view also. You can see which all elements are there, how much is the thickness, all these details are here. So the ICs provide various functions. It's like with the discovery of ICs, it has enhanced the performance of the whole electronics, the whole electronic devices, the whole electronic sector. It's being used in, I've listed a lot of equipments where it's being used. It's being used in radars, computers, juice makers, televisions, I would say video processors, memory devices, audio amplifiers, microwave amplifier, calculator chips, microcontrollers. So all these are some of the areas where they are being used. Now, I hope you know about ICs, right? So today in this session, I would not be able to complete, or I will not be able to go further without discussing two things. The first one is power devices, and the second one is called as the MEMS. It's the micro electromechanical systems. That's called the MEMS. So these two are something called the upcoming part, or I would say we know about semiconductors, or we know about devices which can perform things, which can store data, something called computation and memory, which can compute lot or which can do a lot of calculations, and they can store things in memory. So what is power devices? Or semiconductors that can operate under large current and high voltage is called the power devices. It's like they are used for electricity control and conversion, which operates under higher voltage or higher current. They have the capacity to operate under those conditions. So that's what it will be able to control this power and the voltage, maybe the fluctuations and all. So that's what the great advantage is. Whenever there is a high power fluctuation or something, most of the devices which we are using will not be able to tolerate it. So if we have a set of devices which are able to, a set of semiconductor devices which are able to operate under large current and high voltage, then a lot of innovations will come in different sectors. So we will discuss about all of them in detail. So there are two components which are really important. So the first one is gate turn-off thyristor, and the second one is IGBT, that is insulated gate bipolar transistor. I would say all this is being used in inverters, maybe in different trains. I would say an example. It's like we are going in a train. Have you ever thought about how the electric power is handled? It's like, I would say, something of an inverter type of device which controls the electric power for the running train. They are making use of two devices that we have just mentioned. It's the gate turn-off thyristor and the insulated gate bipolar transistor. So these two devices are used to control the power. What is the reason is these devices may switch on and off maybe thousands or hundreds of times in a second. So we have some devices to control it, control something from happening. So we have this power devices, or we have this power devices which can handle the high voltage of maybe several thousands of volt. This is being used in different, I would say, different trains, different bullet trains, different parts. It's currently in use. There are different inverters which are with the IGBT system used in air conditioners, I would say microwaves, rice cookers, I would say refrigerators, the LCD TVs. So all these areas we are using it. Now the second one is something called hybrid cars. We know a lot of things have changed. Now it's like we are living in a situation where everything is combination, or everything is hybrid. So it's being used in hybrid cars, it's being used in solar cells, fuel cells, then wind power generation firms. So all of them are depending upon something called the power devices. Now I would say silicon carbide or gallium nitride. So all these are some of the materials which comes under the power devices or the power semiconductors, or I would say we call them as the next generation power devices or next generation power semiconductors, because they'll be able to deal with a lot of things, and the loss of power or the power loss, the amount of power that will be lost will be very less. So that's the advantage of them. Even if there is fluctuations, they'll be able to deal with it, and they'll be able to do it in lower power loss. That is something which is very important. Now, I think we'll move on to the next concept, which is called the MEMS. I hope at least some students have heard about the MEMS, which is called the micro electromechanical systems. What can actually be MEMS? It is an ultra system which is composed of micromechanical components. It is having a lot of components. It's like a lot of components are in something called FEMS. We have sensors, we have actuators, we have electronic circuits. Everything is kept up on a silicon wafer. So it's something called a microfabrication technology, or I would say it's something called a large scale integrated technology, where we have a lot of devices embedded on a single chip. What is the main advantages? It's mainly helping in the miniaturization of products, something like the size reduction. It's being used in displays. It's like displays of different or the nozzles of different inkjet printers, maybe different projectors displays. In all these things, I would say gyroscopes or pressure sensors, acceleration sensors, flow rate sensors. So maybe some of these terms may be new to you, but this is something which you need to understand as students, because you are not going to deal with something that's already discovered. You're going to study something or about the innovations that are coming up, about how this field is getting advanced. What are the advancements that has come up in the semiconductor industry? Even I would say we know about the blood test chip, right? Maybe different catheters of medical devices. In all these things, we could see the semiconductors being used. Now, I think in some of the lamination techniques also, we are using them. So what will be the future? Or what can be the future? Or what will be the future of semiconductors? What are the advantages that we will have? The most important thing is we'll be able to process a lot of information in lower time. Maybe the power consumption will also be less. Maybe everything will be safe and secure. So that is something which is going to happen in the coming days. So here we'll be discussing today some of the applications. Maybe what are the applications of semiconductors in different sectors where these are used. So we'll be discussing something related to automobile industry, about the medical industry, about the security systems, about the communication sector. So yes, these are the basic examples I have listed here: television, advanced medical care, maybe your mobile phones, different parts in your cars. So are there any students who are really interested into the mechanical part? It's like, or the automotive part, just wanted to have an understanding. Because you are more updated about this sector than me, maybe updated about the innovations that are coming up. How many of you know the number of chips that is there in a car? Maybe the count of chips that there in a vehicle. There are about 80 to 120 microchips in a car. See the number of chips. So I would say now when it comes to electric vehicles and all, a car or a device, or I would say it contains about 3,000 chips. See the number of chips that's there in the vehicles we are using. So today, when discussing about the semiconductors' importance in the automotive industry, we'll be focusing on three things mostly. The first one is safety and driver assistance. Second one is electrification of vehicles. And the third one is connectivity and entertainment. So we'll be discussing what semiconductor or what role semiconductor plays in all these areas. So yes, how many of you think like our cars are more smarter than us? Now it's like we know everything is becoming smart. We know about the smart home, all the smart concepts. So our cars are becoming smarter than us. So semiconductor plays a very crucial role in these modern vehicles. I would like to call this car or this vehicle or this instrument as a collection of lot of sensors. We are using different sensors. I know maybe you will be able to name those sensors also. Now, more from the mechanical side, it has shifted to the electrical part also. Earlier, we used a lot of mechanical systems to control the devices. Now, we are getting the support of this electrical part also to control the system. I would like to call the car as an advanced data processing unit. How many of you agree? I would like to call car as an advanced data processing unit, which is just moving on wheels. Now a vehicle has changed to an advanced computer. See, it's also computer. It's an advanced data processing unit. So all this is possible, or why I'll be able to call this car as an advanced data processing unit is because we are using a lot of sensors, we are using a lot of technologies. This is only possible with the help of semiconductors. It's not just in car, it's there in every industry. So when it comes to electrification of vehicles, we know it's just a combination of different things, from the automotive or the mechanical or the automobile part to the electrical part. Earlier, it was completely of mechanical side. Now this electrical part has come into existence. So most of the components are an interchange, are as a relationship between the electronic system and the mechanical system. So that's what there is something called design and manufacture of automotive electrical systems. Technology has come up a long way. We have an interchange or we have an exchange between the automotive part and the electrical part. So several functions of the vehicles, it's being controlled by the electrical systems that enables a car to read precise information and helps in increasing their fuel efficiency. I would give you some examples also. It's like what all the semiconductors are doing. How many of you know about the instrument cluster, maybe about the speedometers, about the automatic climate control system, about the infotainment system? Everything is working because of the sensors in the vehicle. The sensors are actually something which is related to the semiconductors, where the semiconductors play a role. Here also the data comes into picture. When it comes to vehicle also, data comes into picture. It's like we are reading a lot of data or a lot of information and we are working on it, working on that data. It's like sensors can track all the values. They can control the combustion of an engine, how it's working, what all things are happening. Even this system can help me to find out what's the efficiency of the combustion system in my car engine. How the battery management system is working, mostly for this hybrid or these electric set of vehicles. They help me to have an understanding about the braking system. So it's like electrification of vehicle, the semiconductor plays a very important role. And the second one is something called electronic driver aids. It's something related to the safety and driver assistance. How many of you have an idea about the three terms that I've mentioned? I have not mentioned their full names, so I want you to give me the names of ABS, EBD, and BNVSP. How many of you have heard these terms? So the first time I would tell you what is ABS. It's the anti-lock braking system. What is EBD, or what's the next term? So this anti-lock braking system and the EBD is being proposed by the norms of the BNVSAB. It's something called the Bharat National Policy. It's something related to the vehicle safety. So what is anti-lock braking system? I hope there are boys in this session and you will be able to give me an answer for this anti-lock braking system. Or I would say we used to call it as an anti-skid braking system. Not only anti-lock, we used to call it as anti-skid braking system. It's being used in almost all the vehicles, cars or maybe trucks or bikes, or I would say buses. In all these vehicles, we use something called ABS. What it is? I'm not able to see anybody typing about ABS in the chat box. I just want to have an understanding what is ABS. Whenever we are pressing the brakes, this ABS or the anti-lock braking system prevents the vehicle from locking or prevents the wheel from locking during the braking. So it's like thereby there will be a contact between the vehicle's wheels and the road surface. So then only I as a driver will be able to control the vehicle. So the anti-lock braking system operates by preventing the wheels from locking up during the braking time. Then only I'll be able to maintain a contact between the road surface and I'll be able to control my vehicle in a good manner, or I'll be able to control my vehicle. I'll be able to prevent accidents. What is EBD? EBD is called the electronic brake force distribution. How many of you have heard these two terms? You can just raise your hands. Maybe if you're not able to type in the chat box, you can just raise your hands. How many of you have heard about EBD? It's also something called a braking technology. It's like controlling the braking or the controlling the system. It's like how much amount of force I need to be applied based on my car, based on the road conditions, based on the speed, based on the load I'm having in the vehicle. So all this is being something called an intelligent control of all these things. Intelligent control of all the braking systems that's being done by EBD. And there is some policy which is called as Bharat New Vehicle Safety Assessment Policy or Program. So we have an assessment scheme It's like, yes, I would ask for the rating. How many of you know there is something called rating when it comes to cars in our country? Is there any car which have scored a 5-star rating in our country? Maybe for at least one rule, one safety rule. Can you name any of the cars who have scored a 5-star rating when it was being tested in our country? It's something related to their safety. Based on the safety performance, we'll be rating the cars. It's being drawn from something, or whatever is happening in India is being drawn from something called the National Automotive Testing and Research and Development Infrastructure Project. As a part of this project, it's being done in our country. Something called the Bharat Stage Vehicle Emission Norms. I hope you have not read about these things. So according to this, every vehicle which comes into the market has to go for 4 phases. They have to complete 4 phases before it gets into the market. Something called a frontal impact, something called a rear impact, or something called side impact. Different types of test. You have heard about crash test, right? Maybe in newspapers recently we have seen something like Maruti is not up to the mark when it comes to crash test. So I would just give you an idea about how many of you heard that Tata Nexon have scored a 5-star ranking when it comes to this ranking. But they have only scored something called 3-star in the case of child or the passenger safety. Now only our country is doing all these things. I would say the Latin, China and European countries, all of them are having this policies maybe long before. We all know it's not about a good driver being a good driver, but we need to consider a lot of factors. So safety is the need of the hour. There are a lot of campaigns which are happening in our country, something called Safe Cars for India, where we are giving more importance to something called the safety, or something called semi-autonomous driver assistance systems, or the intelligent functions. All these things which is happening in a car or in a vehicle is possible by the semiconductor devices. I have listed out some areas where these semiconductor devices are being used. About the blind spot or the D-spot detection, about the reverse camera, about the cruise control, about the line change. I know maybe boys have an idea about all these things. Not only boys, girls are also driving. So you all will have an idea about it. About the airbag deployment, about the different sensors, about the emergency braking system. So in all these things, or all these technologies have come up with the help of something called the semiconductor devices, or all these technologies are working correctly only with the help of semiconductor devices. Now, when it comes to connectivity and entertainment, how many of you know about connected cars? It's like modern cars can be connected. The use of connectivity technology. It's like 2 cars will be able to communicate with each other. Some researchers are going on about the connected cars, and a lot of places they have implemented it also. And we know what technology can provide us, right? It can enable a lot of features like something called GPS or mapping, or maybe can give us information about any emergency closures or anything that's happening. So this human-like sensing capabilities and everything is possible only because of this, or only with the help of these semiconductor devices. I would say the GPS, the mapping, everything. So it's like future car will be something like a combination of different technologies. It's not only mechanical. Now we know electrical or the electronics part comes into picture. Now it will be a combination of different parts. So I think that's all towards the, yes, I have a diagram here. You can see the different areas where semiconductors are used in a car. I have listed out very few of them. It's there in adaptive cruise control, forward collision warning. It's like our device is giving us a lot of warnings. Whenever we are driving the cars, it's giving us a lot of warnings, right? So all these warnings are with the help of, or how they are checking or how they are measuring this is with the help of devices called the semiconductors. So there is something called adaptive cruise control, forward collision warning, automatic energy braking system, or lane assistant, lot of things, right? Different types of warning, different types of modes in driving. All this is possible because of this semiconductors. Now we know EVs are in the market, right? So how many of you think like how this charging things will change, or how the vehicle charging will change? It's like sometimes we'll have this EV batteries. Now we are depending upon different charging stations. A lot of researchers are coming up. A lot of researchers are going on different areas in which we have to rely on solar power. That's the one thing for charging. A lot of researchers, something called photovoltaics. A car should depend upon solar power, or maybe we can have batteries which can help us in the purpose of charging. So something called it's something called a part of clean energy. Lot of researchers are coming up, so I thought I would give you this idea also. And when it comes to India, we are not having anything related to the semiconductor industry till now. So I hope you students have heard about the government's decision of setting up or aiding up, I would say about 76,000 crores for creating a semiconductor ecosystem in our country. And I think the project has started. It was the semiconductor laboratory at Mohali, the first process which was given by our Prime Minister. So inviting the semiconductor industries to start up in India, and that too in full level, from the basic process to the final product. So it's something which is going to happen in our country. Now I think we'll move on to the next important industry, which is something called medical industry. Semiconductor plays huge role in medical industry. I think I have given a set of examples in the diagram itself. In the nebulizers, ventilators, X-ray equipment, ultrasound equipment, it's like different robots, different drug delivery systems. There are electronic beds, infusion pumps. Everywhere we could see semiconductors. It's there in remote healthcare. It's there in ventilators. It's there in continuous glucose monitoring machines. It's there in infrared thermometers. It's there in oximeters. It's there in pacemakers. It's like now they have given us, or they have helped us in patient monitoring. I would say before the COVID virus, we were not having an idea about these many health systems. We are going to the hospital, we are having regular visits, we are doing different things. But we were not having an idea about the different devices or different sensors that we could use, and we could analyze our own things. Something called continuous glucose monitoring. It's something called, have you ever heard about the wearable insulin pumps? It's there already. So placing a sensor on your skin, which transmits information like what is your blood sugar level, what's the level, is there any fluctuation? If there is fluctuation, this device can also send a small amount of or small doses of insulin to your body. So see what all things have happened. It's only possible with these sensors, and it's a part of semiconductor. Now, when it comes to ventilators, so those patients who are having severe damages, maybe lung or anything. So these pacemakers are a very important thing for these people. So it also contains the semiconductor chips it's like to determine the oxygen rate, the amount of breath, how much amount of oxygen they need. It will work according to the needs of the patient. So that's also a device which requires the semiconductor to work with. Now, another big area is something called the portable ultrasound devices. Lot of devices are there, lot of portable devices are there, which we are using in our homes. Maybe to identify the amount of oxygen which is in our body. Maybe I would say different doctors. After this, I would say the COVID, I would say a lot of innovations have come up from different doctors. I would say an example. In China, these doctors have, have a device which will find out the pneumonia if the patient is having a pneumonia or that type of infection. It's being possible by the electronic device or an ultrasound device. What it does is it's being used by something called piezoelectric crystals. They have made these devices into something called semiconductor chips. So these chips can help to find out if they're having any lung infection or if they're having any breathing problem. So see what industry has done about the oximeters, about the different IC circuits that's used in drug delivery, about the continuous glucose monitoring systems. So the bio field or the medical field, the healthcare sector has seen a lot of advancements because of the semiconductor devices. They are coming up with a lot of new devices, or it's like, I would say ECG machines. So all this have used, or all this are currently using the semiconductors in the sensors. Now moving on, we have something called the security system. So when it comes to cybersecurity part, there is a lot more to do with the semiconductors, whether it's secure boot or whether it's mutual authentication, whether it's secure communication or whether it's encryption, or even it's being used by the defense in different areas. So I have a question to all of you. How many of you feel like why semiconductor is this much important? Why there is a lot of news that's coming up till now in newspapers because of the semiconductor? What is the reason for this? The reason is because a small semiconductor chip that you have seen requires minimum of 3 months to manufacture it. That's the minimum time. So manufacturing a chip typically takes more than 3 months and involves giant factories, dust-free rooms, multi-million-dollar machines, molten thin laser. So just the basic requirement. So when a small chip is taking this much time and a lot of innovations are coming up in such a way that every single thing that we as people need requires these small, tiny semiconductor devices, there will obviously be a shortage, right? So how the shortage actually started is when the pandemic came, there was a drop in vehicle sales, right? So a lot of companies, even I would say the Maruti, the Hyundai, or the Tata, they have dropped or they have reduced their demand for the semiconductors. But during that same time itself, our education, everything has changed online. So in a home, it's like 2 or 3 people are there, they are working with different devices. So it's like the number of devices that is needed, the electronic devices, the need of these devices has increased. So when the car sales have started in 2020 later, it's like after the COVID, there was a steep high sales. So all the companies have freezed their request for the semiconductors. Now it's like it was a bulk request. How many of you know this is the recent cuttings that I've taken from some newspapers? It's like people have to have the waiting period of 8 to 6 months before getting a car. It's not like they can just go and buy a car. I would say Maruti is having about 4 lakh cars to be delivered. So it's like they are having this much pending orders. This is because of the one thing was COVID-19 pandemic that we have already done. And the second one is because of the global semiconductor shortage that has happened. So every industry is getting affected because of the semiconductors. Now see the different countries which are manufacturing semiconductors. It's like we are just in the initial part. We are just planning to start up the industry, start the market. So you have heard about the war between the US and China when it comes to the semiconductors, right? So the US, it forms about 47% of the global semiconductor sales. Then there is Japan and South Korea. All of them have increased production. So Taiwan is 7%. European Union, it's 10%, Japan, it's 10%, South Korea, it's 20%, China, it's 5%, US is 47%. And every country has increased it because of its demand or because of its need in the world. Now, see the different types of markets which are using, or see the market share of the semiconductor share. It's there in networking and communication. It's being used by the automobiles. It's being used by the electronic sector. It's being used by the data processing sector. See the range. So every industry is making use of the semiconductor devices, or every industry needs them very badly. Now, what is the future of semiconductors? Have you ever thought about what is going to happen? I would like to introduce 2 things before you. So the first one is SoC, which is called as a system on chip, and the second one is something called an IP core. We'll just discuss what is SoC, what is IP core, because this is something called the future. SoC is called a system on chip. So you have understood it's like a system, a complete system on a single chip. That is what is called SoC. So it's an IC or an integrated circuit which takes a single platform integrates an entire electron into I call that circuit as an SoC. It could have maybe CPUs, it could have memory, it could have output port, it could have different signals. So it includes a central processing unit, input and output port, maybe internal memory, analog output blocks. So all these systems I have to keep on a single chip. So why this is being done is it can be used in different fields. It can make advancements in different fields. I would say it can work with artificial intelligence. It can work with wireless communication. It can work with signal processing. So the need is really high. So I'm having a whole system or whole electronic part in a chip. So a lot of researches are happening when it comes to this SoC. And moving on, and I would say there are a lot of drawbacks or pros and cons to it. So if I'm having all these systems, if one part of it gets damaged, the whole thing needs to be replaced. And the cost and the initial part is really, we need to be really careful with the initial part, how to implement this, how it's going to work, how am I going to embed all these things into a single one. So the developmental cost and everything will be high, but it will be a revolution to the electronic system or electronic sector. It's like whole thing on a single chip. Now moving on, after SOC, we have something called IP core. When it comes to semiconductor, we have to have a reusable unit. So IP core is something called a reusable unit of logic or functionality, or maybe a cell that is developed with the purpose of giving into multiple vendors, and it can be used by these vendors for different purposes. It's like a whole system or a logic unit which is designed with and it has to be licensed and it has to be supplied across different people. It's like SOC or IP core is it's just in the beginning stage, and there are different types of cores also. I would say soft core is there, hard core is there, a lot of innovations are coming up. Now, what will be the role of semiconductors in tomorrow's technology? Semiconductor will have a huge role to play, whether it's AI, whether it's natural language processing, whether it's machine learning. Semiconductor will have a huge role to play in all these areas, or in almost all these areas. So semiconductor innovation is the engine that drives all these promising technologies. It's a very important part in all the promising technologies. So these are some of the top 10 semiconductor companies. I hope at least some of you have heard about it. Texas Instruments is there, ASE is there, NXP is there, Qualcomm is there, TSM is there, INTC is there. This is something called a basic knowledge that you should have. What are the semiconductor companies, how they are doing it, which countries are owning the global share, what is happening to this industry, why Maruti is facing this much difficulty in delivering cars. It's something called, you have to open your eyes and you have to find out that this small chip or this small thing is affecting the world in this way. Or it has the control of a lot of things that is happening around. So I hope I have come to an end towards the session. If you have anything to ask, you can type that in the chat box. And I hope everybody has received a basic idea about the semiconductors, about the semiconductor industry, about the different sectors where semiconductors are being used. So if you have anything, you can just message me. And thank you so much, students, for attending. Thank you all. And if there is anything, I'm just looking into the chat box. If there is anything, you can just type it in the chat box. And I hope the session was useful. And tomorrow we have a mathematics topic. And after that, on the final day, we have an alumni with us who is a data scientist, a mechanical engineer, and works in an EV sector. So it's a combination of different things. Be ready with your question. He'll be ready to clear all your doubts. So thank you so much for attending. If you have any queries, please feel free to contact me. Thank you all.